Hey, math people. It's me again, ready to do some math, some 3D geometry in particular. Can't wait. What have we done so far this unit? Ooh, color changer. We've done the basics. We've gone over vocab. We have done surface area of prisms, surface area of pyramids. We're now going to the other part of 3D geometry, and that's going to be volume. So we've got a couple volume lessons coming down the pike. Today, we're going to be working on the volume of prisms, and in particular, the volume of rectangular prisms today. Um, so, first off, what is volume? Like, what does that word even mean? I think some of you were getting ahead of yourselves when we started this unit and figured, oh, everything's going to just be the amount of space that a shape takes up. But that is what volume is, not surface area. If you were paying close attention to one of the other videos, one of the things that I mentioned was if you had a cereal box, for example, because for most of us we can envision a cereal box. If you were to carefully peel that box apart and lay it flat and look at all of the stuff that the advertiser or the cereal maker put on the box. So you've got like the funny pictures, you've got the logo, you've got a picture of a cereal, you've got your nutritional information, blah, 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 blah. All of that stuff is taking up the surface of the box. That's surface area. Volume, on the other hand, is when that box is folded up and it's got yummy goodness inside, how much cereal fits in the box. That's volume. How much stuff can fit inside of the box. So volume is for a three-dimensional figure, it's the measure of the amount of space that that 3D figure occupies. And volume is going to be measured in whatever the units are, cubed. So cubic units. So if it's inches, that would be inches cubed. If that was feet, it would be feet cubed. Um, and we'll talk about why in a little bit. But anyways, on to the good stuff. I really enjoy this lesson for a number of reasons, but one of the things that always makes me laugh is people are like, ah, I already know how to find volume of everything. It's just length times width times height. And it's not length times width times height for everything. That doesn't work, nor does it make sense that every figure would have that formula, because not every 3D figure has a length and a width and a height. Think about a triangular prism. Think about a pyramid. They don't all have lengths and widths and heights. Cubes do, rectangular prisms do, but not all shapes do. So we try our hardest to set the record straight and to set you straight in your volume learning by using the formula that works for every single shape no matter what. The volume is found by multiplying big B times little h. What does that mean? The volume of a prism is the product of, and I'll use a different color, this B stands for the area of the base shape. Whatever shape is the base of the prism, you are going to find the area of that flat shape. So let's say you had a triangular prism. You would find the area of the base, which would be a triangle, thus the name triangular prism. For a rectangular prism, which is what we're going to focus on today, you're going to find the area of the rectangle, and then you're going to multiply it by h. And in this formula, that is the height from base to base. So step one is going to be, what is the base shape? Figure out what the base is. What are you working with? And then step two is going to be, find the area of whatever that base shape is. And then step three, determine what the height of the prism is. That means once you know what the base is, it's the measure from one base to the other base, and then you're going to multiply by that height. So again, the volume of any prism, no matter what type of prism it is, can be found by using this formula. Big B times little h. Big B represents the area of the base. H stands for the height of the prism, aka the distance from base to base. So in this shape right here, the base shape, I used red for a reason, is going to be this rectangle. And the other base is down here. You can't see it. I mean, you can see it, but if it was a 3D shape, you wouldn't be able to see it. But it's this rectangle. And a rectangular prism has three measures. It has a length, it has a width, and it has a height. And that's why so many people sometimes say, oh, prisms, it's length times width times height. But not all prisms have these three measures. A rectangular prism does. And why do we multiply length times width times height? Well, because the base, which is a rectangle, you find the area of that by doing length times width. And then what do? You multiply it by the height of the prism. The height of the prism is the height from base to base. So that's why it's length times width times height. What is it really though? Big B times little h, area of the base times the height. So let's look at this in practice. Here we've got a beautiful green rectangular prism, and it has three measures. It's 7/8 of a meter long by 1/2 of a meter wide, and it's 5/8 of a meter tall. Well, we just talked about the fact that volume is equal to the area of the base multiplied by the height of the prism itself. So that's going to leave us with the area of the base. The base is this rectangle. And that's going to be length times width. How do you find the area of a rectangle? You multiply length times the width. So 7/8 times 1/2. So that's the area of the base, a rectangle, times the height of the prism, going from base to base. And that's going to be this measure right here, which we are shown as 5/8. So now this just becomes a subtraction multiplication problem. 7 times 1 times 5, that's all the numerators multiplied by one another. That's 35 over 8 times 2 times 8, which if you do that multiplication, you will get 128. So that means the volume of this rectangular prism, aka the amount of space that it occupies 35 128ths of a cubic meter. 35 128 meters cubed. Why is it meters cubed? Well, what did we multiply here? 7/8 meters times 1/2 meters times 5/8 meters. Altogether, we multiplied this thing by meter times meter times meter, meters cubed. That's why it's meters to the third power as the label, because we've multiplied this by 3 different dimensions, length and width and height. 3 dimensions got multiplied together, meters cubed. Fun fact. Another example for those who'd like to see an extra one. We've got this beautiful pinkish red hued rectangular prism, and volume is found by doing the area of the base, big B, times the height of the prism itself. Well, the base is this square. And how do you find the area of a square? The area of the base, length times width. So that's going to be 3/2 times 3/2 times the height of the prism. The height is from base to base, and that's going to be this distance here, which is 3/2. Ooh, the length, the width, and the height, they're all the same. That makes this a cube. Length times width times height. All right, here we go. So to do this, I'm going to multiply 3 times 3 times 3, aka 3 cubed, which is 27. And then 2 times 2 times 2, aka 2 cubed, which is 8. 27/8, but let's make this a little bit nicer, simplify it. That would be 3 3/8. Therefore, the volume of this cube, the amount of space that it takes up, is 3 3/8 cubic inches. And there you go. And you know how much I love math and how much I love you. I wouldn't leave you without doing some sort of word-ish problem or like better application. So here you've got this computer tower. You might have seen one of these before, especially if you are a computer gamer. Usually you have something that's a little more powerful than your standard Chromebook, laptop, or home computer, and they sometimes look like this. Anyways, this type of problem is a little bit different. This is find the missing measure of the computer tower. We know that this computer tower takes up 1,792 cubic inches of space. We also know that it has a length of 16 inches and a width, it's 7 inches wide. But how tall is this thing? What's the height? Well, there's one way to find out. There's a couple ways to find out, but the way we're going to use is we're going to work backwards. We're going to do volume equals the area of the base times the height, and we're going to plug in what we do know and then solve for what we do not know. So we know the volume is 1,792. We know that the area of the base, aka big B, is found by doing length times width, which we know. We both know both of those measures. We know 16 and we know 7, length times width, area of the base. And we don't know the height. So now all we're going to do is we're going to work backwards and solve. The first thing that I'm going to do is I'm going to multiply 16 by 7 just to simplify it a little bit. So 16 times 7 is 112. 112. And now I'm going to use some inverse operations. I'm going to divide both sides by 112. Divide by 112. And that's going to give me a final answer here of 16 inches is equal to the height of the computer tower. So, final answer, this computer tower, its missing measure is a height of 16 inches. Happy day. I hope you enjoyed learning a little bit about computing the volume of rectangular prisms. We'll be back doing other shapes throughout the rest of this unit. Happy Wednesday. Enjoy yourselves, but not too much. I know it can be super fun doing math. Don't have too much fun. See ya.